Okay, so the people who are in this group are Dakota Thompson, Lunia, Samantha, and the person who is filming is Mykel. So what we are going to be talking about today is the washer method, which is used when a function has an outermost radius and an innermost radius. And the equation is volume equals pi times the integral from a to b of the outer radius squared minus the inner radius squared with respect to x.
So when you have a function, or in this case two functions that have an enclosed area, and it's revolved around the x-axis or horizontal rotation, you're finding the infinite volume of the number of circles from the outermost radius, and you subtract the total number of circles from the innermost radius. So for example, this capital Rx represents the radius of the function on top, right here. That revolves around, and you find the total area of that volume, which represents this. Then you subtract the radius from the axis of rotation to the next lower line, which in this case is a horizontal line, and that accounts for the whole.
Okay, so for example, if we have this potato here, and there's a hole in the middle, and if we're rotating it around the x-axis, which would be right here, we're rotating it around. To find the volume of it, we have to take this part right here, the area of this, which would be the big capital Rx, and subtract it from the radius from here to here, which would be the little x. Okay, so for the washer method, we have discs being created, and you infinitely cut the amount of discs, and for it, you just take the volume of the discs and add them up all over to get the volume. Okay, so for this video, we're doing the shell method, and it has Dakota, Mykel, Lunia, and myself, Samantha. The equation for the shell method is the volume equals 2 pi times the integral from a to b of the radius, which is right here, times the height of the function.
So as the function, or as the shaded region revolves around the axis, we're finding each layer, the volume of each layer. So in this case, the radius revolves around the y-axis, and the radius, in this case p of x, will represent this part of the function. And then the height, h of x, is the function f of x. So we're finding each layer with respect to that, and the 2 pi represents the circumference of each one.
Okay, we can represent this with our potato again, as it's rotating around the y-axis. What we're doing is we're going to peel off this layer of potato and find the volume of each individual layer, and continuously, infinitively, continue peeling and finding the volume.
Okay, we're done.